All right, let's run through these examples to get you ready for your quiz for tomorrow. The first three are going to ask you to graph using your vertex and tables. Remember, your vertex is opposite of b over m. So your b is the number that's being added or subtracted inside that absolute value. So my vertex for this problem is going to be negative 2 over 1, or negative 2, comma, and then what's being added, or your c, there's nothing there. When you make your table of values, you put your vertex in the middle, and then you pick numbers to the left and to the right, and you're going to plug those in and calculate your answer. So negative 3 in here gives me negative 1. Absolute value is 1 times 3 is 3. Negative 4 in here gives you negative 2. Absolute value is 2 times 3 gives you 6. Negative 1 in gives you 1. Absolute value is 1 times 3 is 3. And 0 gives you 2. Absolute value is 2 times 3 is 6. Remember, if you do it correctly, your table should repeat, and it did. And then as long as you graph those points, that should make your V. I didn't save myself a lot of space here, so if you want to go ahead and graph it on your sheet, you can, but make sure you're graphing these as ordered pairs, connecting the dots, and then putting arrows on the ends of your lines. This one, to get the vertex, you take the opposite of b, which would be positive 5, over m, which is 2, so 5 halves, or 2 1/2, nothing being added there. Make your table, put that vertex in the middle. Now this is 2 1/2, so 2 and 1 are going to be to the left of it, and 3 and 4 are going to be to the right of it. Now you plug those numbers in to calculate. 2 gives us negative 3, absolute value is 3. 2 gives us negative 1, absolute value is 1. The 5 halves we have, plug 3 in, we also get 1. Plug 4 in, we also get 3. Again, you can graph those dots as ordered pairs. Go right 1 up 3, right 2 up 1. This you have to just go right 2 1/2, and then kind of estimate about where that's at and connect your dots. This one, for the vertex, you're going to use opposite of b, so negative 2 over m, which is 1/3, comma, and then your c is negative 3. You do need to simplify this in order to work with it. If you take negative 2 and divide it by 1/3, that's the same thing as taking it times 3 over 1, or the reciprocal. So your vertex on this particular problem is negative 6, negative 3. So negative 7, negative 8, negative 5, negative 4. Plug those in. Now, we probably shouldn't pick those numbers, because when I go to plug in, I have to take 1/3 of it. So I would maybe suggest going back and picking multiples of 3, unless you are comfortable with using fractions. So the multiples of 3 to the left would be negative 9 and negative 12, and the multiples of 3 to the right of it would be negative 3, and then 0 would be easy to work with. So plug in negative 12, you get negative 4, plus 2 is negative 2, absolute value is 2, 2 minus 3 is negative 1. Plug in negative 9, you get negative 3, plus 2 gives you negative 1, absolute value is 1, 1 minus 3 is negative 2. And your table should repeat, but you want to make sure, plug in negative 3, you get negative 1, plus 2 is 1, 1 minus 3 is negative 2, and then 0 would give you 2 minus 3, or the negative 1. And then again, graph these as ordered pairs, and it will make a V. All 3 of these V's should be pointing up. There is no negative out front. Just remember, if there's a negative out front, that you, after you take the absolute value, you take the opposite of it before you do any adding or subtracting. All right. These 3 I want you to graph using translations. So you should look at this and say, because it's inside, that's going to tell me to go left or right, opposite of what it says to do. So this particular graph is asking me to go right 3, put a dot, and because it's positive, it means cut the corners going up and to the left and up and to the right. This one, because the number is outside of the absolute value, that tells you what to do up or down or vertically. So this one says go up 2. And again, this one is also positive, so the graph is going to point V up. This one has both a horizontal and a vertical move. So this one is going to go right
1, because we always do the opposite of that number, and then down 2. So right 1, down 2 is my new vertex, and because of that negative out front, it's going to cut the corners down each way. So that's the graphing part of your quiz. So there'll be 3 of each kind, 3 tables, and 3 using the translation or shortcut. All right, then these I'm giving you information about the graph. You have to write the inequality. So this one already tells you to use the absolute value, the positive absolute value function. Remember, anything left or right goes inside, anything up or down goes on the outside. So this inequality is y, or this equation is y equals absolute value of x. Since it says left 5, that's going to be plus 5. And then behind it will be a plus 3 to show the up 3. This one has a negative in front. It's kind of hard to see because of my graph space. This negative just stays with the absolute value. It means the graph would have been pointing down. Right 3 would be a minus 3, and down 2 is a minus 2 behind it. They're not asking you to graph, so don't worry about this being a fraction. The fact that it's saying go right, that goes inside the absolute value with the x, and we do opposite sign of what that says. So we're going to subtract 2/3 on the inside. Don't worry that it's a fraction. I'm not asking you to graph it. This one, I'm giving you the graph. You have to come up with the inequality. So first you have to recognize that this is a negative absolute value because it's pointing down. Put the x on the inside, then figure out how far it went left or right. It went 1, 2 to the right, which makes it a minus 2 on the inside. And then it went up 1, 2, 3, 4. So it'll be a plus 4 behind. And those will be the last 4 problems on your quiz of writing the equation.